Forces and vectors. So, just to recap what we already know about forces. A force applied to a particle has both a magnitude and a direction. So force is also a vector. The force causes the particle to accelerate. And remember that force is equal to mass times acceleration, where m is the mass of the particle. Right, let's look at a couple of examples of forces and vector questions. You could also be asked to look at forces on an incline, which we've done before. We're just going to have a look at two basic questions to do with forces and vectors. It says a constant force F newtons acts on a particle of mass 2 kilograms for 10 seconds. The particle is initially at rest, and 10 seconds later it has a velocity of 10I minus 24J ms to the minus 1. Find the force F. Right, remember, to find the force, you do force equals mass times acceleration. Well, we don't have the acceleration here, but what we are given is we're given its speed after 10 seconds, its initial speed, and the time. So we can find the acceleration using SUVAT. So, let's write down what we know for a SUVAT equation. SUVAT. Well, we know the time is 10 seconds. We need to find the acceleration. The final velocity is 10I minus 24J. And we know that initially it's at rest. And we don't need to know the distance travelled. Now, remember, to find acceleration, it's the change in velocities divided by the time, which is one of our equations. A equals V minus U over T. So let's put in the information we know. So A equals 10I minus 24J minus 0, because the initial speed velocity is 0 and the time is 10 seconds. So if we work this out, we get 10I minus 24J over 10, which becomes I minus 2.4J. Now we know the acceleration, and we also know the mass. The mass of the particle is 2 kilograms. So we can use the formula F equals ma to find the force. So F equals ma. So F is 2 times I minus 2.4J. So if you work that out, you get F equals 2I minus 4.8J newtons. Right, let's have a look at another example. It says forces F1, F2, F3 act on a particle of mass 3 kilograms. Find the acceleration of the particle. Let's just quickly draw an exact diagram for this. You've got your particle in the middle. You've got a 2I acting on it, plus 4J. You've got a minus 5I plus 4J. And we've got a 6I minus 5J. So 6I minus 5J. So to find the forces acting on this particle of mass 3 kilograms, what we need to do is we need to combine all these three forces to make one overall force, and then use the equation F equals ma. So what we're actually doing in this question is we're doing F1 plus F2 plus F3 is equal to mass times acceleration. So we're going to add together our three forces given. So we've got 2i plus 4j, and we've got a minus 5i plus 4j, and we've got a 6i minus 5j, and that's equal to ma. So let's combine together our I components and our j components. So if we collect together our I components, we get 3i, and if we collect together our j components, we get 3j. And that's equal to mass times acceleration. So our 3i plus 3j is all our forces combined together now to make one overall force acting on this particle. So now we know that the mass is 3. We're trying to find acceleration. So all we have to do now is we do the force 3i plus 3j divided by 3. So our acceleration is going to be I plus j, ms to the minus 2. As I said, you could also be asked to do a question involving forces and inclines using vectors. And it's exactly the same techniques as you've done before.